Hello everyone, it is my third lecture and it is the last lecture of the data transfer instruction group. So, in this group we will discuss first SPHL. The opcode is SPHL and there is no operand, it is a 1 byte instruction. And the meaning of SPHL, the meaning of SP is a stack pointer, HL is a register pair of HL. So, the meaning of SPHL is copy HL pair to the stack pointer, means this instruction load the content of HL pair into the stack pointer. So, the value of stack pointer is depend upon the HL pair. It is a very simple instruction. Next instruction is XTHL. XT. The meaning of this instruction exchange HL with the top of the stack. X stand for the register pair, T is the top. So it is also 1 byte instruction. The content of L register are exchanged with the location pointed by the content of the stack pointer. The contents of H register are exchanged with the next location of the stack pointer. It is also very simple instruction. Now PCHL. Here PC meaning it is also 1 byte instruction. PC is a program counter, HL is a HL register pair. Load the program counter with HL content. The program counter is loaded with the HL content. Meaning of this instruction, the content of register H and L are copied into the program counter. Program counter, it is also 16-bit address which is directly connected with the HL register pair, PCHL. Now next instruction is push. It is a very important instruction, and push and pop. There is a two instruction which is very popular and generally asked in a GATE or ES examination. So what is the meaning of push? Push is generally used as for a register pair. Register pair means either it may be BC, DE, HL or PSW. It is a program status word which is combination of accumulator and the flag register. So the meaning of push, the content of the register pair are copied onto the stack. Listen very carefully, the content of the register pair copied onto the stack. Stack pointer is decremented and the content of the high order register, it may be B, D, H or A. A when we are using push PSW, program status word, are copied into the stack. Stack pointer assign decrement and the content of the low order register, that means if it is B then it is that low order is C, if it is D then here low order is E, if it is H its lower order is L, if it is A then its lower order is flag, are copied into the stack. Let's take an example. Let's suppose we have a stack pointer whose location 2099 and there is a register BC whose value is 54 is B and 79 is C. Let's suppose we are using push B. Very important thing, where we are using push, it is decrement then copied. Very important, it is decrement then copied. What is the meaning of decrement then copied? Means whatever the value of stack pointer, first it is decremented by 1, then the value of high order register pair is copied to the stack, then again it is decremented by 1 and then the value of the lower order register pair is copied to the stack. So after execution of push B, if it is the situation of the stack pointer and the value of BC, first 2099, it is 2099, it is decremented by 1, that means it becomes 2098, and high order here BC, it is the high order is B. So what is the value of B? Is a 54. The 54 is copied into the stack, then again it is decremented by 1, then the value of low order register pair, that means 79, is copied to the stack, and the stack pointer, now the stack pointer becomes 2097H. It's a very important instruction and very confusing. Now next, pop. Pop is just a reverse operation of the push. That means push, pop is also register pair or PSW. PSW means program status word, which is the combination of accumulator and flag. Pop. The content of top of the stack are copied into the register pair. The content of location pointed out by the stack pointer are copied to the low order register, then it is incremented by 1, and the content of the location are copied into the high order register. So let's take an example. Let's suppose, as we previously left the example, let's suppose the stack pointer value is 2097H79, and here 2098 have a 54. Let's suppose 2097 have a 79 and 2098 is a 54. If we write the instruction pop H, so in pop H, first it get, then increment, where in a push, first it decrement, then it get. Here pop, first it get, then increment. The meaning of get means first is copied to the content of the stack pointer, then it is incremented by 1. So let's suppose the value of stack pointer is 2097. So here the content of 2097, it is a pop H. So here the high order is H and the low order is L. It is a just reverse order operation. After execution of this instruction, the content of lower order of register pair, that means L, is copied by the stack pointer, then after it is incremented by 1, 97 means it becomes 98, and the content of the high order register pair copied with the stack memory, that means 54. Again it is get, then again it is incremented by 1, so the value of a stack pointer become 2099. So first it get the content, then after it is incremented. So it is a push and pop instruction. Next, there is a two instruction, out. It is a combination of two instruction, in and out. It is basically it is a 2-byte instruction. The meaning of out, here is a out is a opcode and 8-bit port address. 8-bit port address means it may be 002 FFH. So in this instruction, it copy the data from accumulator to the port with the 8-bit address. That means basically it is copied to the content of the accumulator and transfer to the output port which is given by this address. That means the content of the microprocessor is transferred to the given port. Let's suppose here is a out 78H. So let's suppose we have in accumulator the content is a 50H. So this 50H is transferred to in 78H port. There is the in operation. In operation means it gets the data from the port. It gets the data from the port. So the content of in given port is copied to the accumulator. Like if we are using in 8C, So whatever the content have in 8C, it is copied to the accumulator. So it is the in and out instruction. So it is all about the data transfer instruction. Now we are moving our next instruction set group, which is the arithmetical instruction, arithmetical and logical instruction. There is a very important point which is always remember that in the data transfer instruction, students, please write down this important point. In data transfer instruction, there is no flag affected in data transfer instruction. No flag affected in data transfer instruction. But in arithmetical and logical operations, the flags are affected according to the operation or instructions. It's a very important point. So a few points we have to remember in arithmetical instruction. As we know, and earlier we discussed that the accumulator is a part of the AL unit. So the maximum results are stored in the accumulator because it is directly connected to the arithmetical logical unit. As we here can see, any 8-bit number or content of the register or the content of the memory location can be added to the content of the accumulator. The results are stored in the accumulator. No two other 8-bit register can be added. That means we cannot add B with C, we cannot add D with E. Always the addition performed by the or with the help of the accumulator. As the subtraction here is also, as we know, in here the subtraction is performed in the form of 2's complement. Increment and decrement, which is also performed, increment and decrement performed in any of the register. It may be A, B, C, D, H, L. So in arithmetic instruction, the first instruction is add R or M. Here R may be any of the register. It may be A, B, C, D, E, H, L or M. M is a memory. As we know the meaning of memory, it is directly connected with the location of HL pair. It is directly located the content of the HL pair location. So if we perform add R means the content of the register or memory are added to the content of the accumulator. The result is stored in a accumulator. Always the result is stored in the accumulator. There is some expansions which we'll discuss later. So let's take example add B. So meaning of add B is A is equal to A plus B. Means as we write the instruction add, the meaning of add is equal to A is equal to A plus, and whatever the operand, if it is B, then here we write the B. If it is C, here we write the C. If it is L, here we write the L. If it is M, here we write the M. And it added both the register. That means this register and the content of the result is stored in a accumulator. Next, ADC. That means here AD means add and C stand for carry. That means add a register or memory to accumulator with carry. So if it is used for a multi-byte addition, if in a previous instruction there is a carry for addition, then this carry is transferred to the next group. So in this case we can use this instruction ADC. The meaning of ADC, add with carry. So let's suppose we are taking example ADCB. The meaning of ADCB, A is equal to A plus B plus CY. As we know, meaning of add B is A is equal to A plus B, but here we are C. C stands for carry. So carry. So carry may be 0 or 1. It may be 0 or 1. So it added with the carry, and this instruction is generally used for multi-byte addition. Next, ADI. As we earlier discussed, the meaning of I is immediate. AD stand for, here AD stand for add, I stand for immediate. If immediate, that means operand should be 8-bit data. Like here we take example ADI 45. So the meaning of ADI 45 is A is equal to A plus 45. ADI means add immediate. So A is equal to A plus 45. So the data may be 00 to FF. It may be FF, A8, 89, whatever you want to add immediate. It added with accumulator and the result is stored in accumulator. Next is ACI. That means add immediate to accumulator with carry. That means A is equal to A plus 8-bit data like 45 plus carry, whatever the carry have in the previous instruction. So it is very, very simple. Next is a DAD. So it is a different instruction. Here DAD is used for a 16-bit addition. So DAD DAD, here is a register pair, and the meaning of this instruction, add register pair to HL pair. And please, it is a very, very different instruction. So the 16-bit content of the register pair are added to the content of HL pair. So whatever the register pair, what is the register pair? It may be BC, it may be DE, it may be HL. But here the result is stored is only HL pair. It is exception case. As we said, the maximum operation are performed by the accumulator, but there is a some operation which have a different meaning. Here it is a DAD instruction. So the meaning of, like if we write a DAD B, so what is the meaning of DAD B? DAD B, that means HL is equal to HL plus PC. Very, very important. Here operand should be register pair. As we write the DAD instruction, the meaning of DAD is HL is equal to HL plus. If it is DAD H, that means HL is equal to HL plus HL. If it is DAD B, that means HL is equal to HL plus BC. If it DAD D, that means HL is equal to HL plus TE. Very, very important instruction. And one more things, there is no flags are changed. Very, very important. So next instruction in this group is a sub R or M. It is similar to addition operation. As we write add, you understand A is equal to A plus, and if it is B, then it is B, it is C, then it is C. Here, sub R, the meaning of sub R, sub means subtraction, subtract with the register. So it is similar to the add, as we write example it as a sub B. The meaning of sub B is equal to A is equal to A minus B. It is sub M, that means A is equal to A minus M. Very similar instructions. It is SBB. Here SB stand for the subtraction and B stand for borrow. That means subtract the register or memory from accumulator with borrow, like it is SBB B. So it will be A is equal to A minus B minus 1 if it is a borrow. Sorry, it is not minus 1. It is A is equal to A minus B minus CY. It depends upon the carry flag. The meaning of subtraction, A is equal to A minus B if borrow is also represented by the carry. Okay, so if there is a carry, then A is equal to A minus B minus CY. Next, SUI, subtract immediate. Subtract, SU means subtract, I stand for immediate. SUI is operand and opcode, sorry, SUI is opcode and 8-bit data is operand. Like if we write the SUI 45, the meaning of this instruction, A is equal to A minus 45. And also, as we know, the result will also, where the result is always stored in accumulator. SBI, it is not a State Bank of India. It is subtract immediate from accumulator with borrow. Subtract immediate from the accumulator with borrow. So the 8-bit data and borrow flag means carry flag. It is subtracted from the content of the accumulator, and as we know, the result is stored in a accumulator. We can take a example from SBI, like SBI is 45, means A is equal to A minus 45 minus carry flag. So it is all about the addition and subtraction. After that, it is a INR. What is the meaning of INR? It is an increment in register. INR, it is the increment in register. Register may be A, B, C, D, E, H, L or memory. So after executing this instruction, whatever the content have in the register, it is automatically incremented by 1. Like if we INR B, so if before executing of INR B have 78H, and after execution of INR B becomes 79H. So what is the difference between a addition and increment? In addition, after performing the addition, the carry flag will affected, but after executing the INR, the carry flag is unaffected. Very important. I and X. Here in the previous instruction it is the I and R. Here I and X. Meaning of X, as we previously told about, the IX means register pair. So I and X means register pair. Here is the opcode I and X, and operand means it may be any register pair like B, C, D, E or HL. So it is directly incremented the register pair. So the meaning of INX is HL plus 1. After execution of this instruction, whatever the content have in HL pair, it is incremented by 1. Next, DCR. What is the meaning of DC? It is a decrement. Meaning of DC, it is a decrement. Decrement in register. So whatever the content of any register, it is decremented by 1. That is decremented by 1. And DCX. DCX means DC means decremented, X means register pair. So whatever the content have in any register pair, it is decremented by 1. So students, it is all about the arithmetical instruction, and please see the video at least twice to understand the meaning of the instruction. It is very, very important, and I will give you some questions. You have to write a program to add two 16-bit number using that instruction. So we will discuss on discussion lecture. Thank you.